All right, I'm going to move on to bullet point 5 here, and I'm going to talk about building KPIs and building basic calculated members, and where we use the two programming languages in the two areas. Now, in this one, because I've done prior presentations on building KPIs over in the OLAP side, I'm going to actually focus more on the tabular side because a little bit more work is required here. So, as an example, let me hop over to Excel. And in Excel, I've got a pivot table that I built ahead of time against a tabular model. And it's using AdventureWorks, and it's pulling in employee sales for a quarter and comparing it to the quota. Now we can, in the drop down here, okay, I built this as a static database so I can't interact with it. I'll just simply stick with the one date here. For quarter 4 of 07, or if I want to look at this for a year, I can get the breakout of sales, quota, percent of quota, and then a visualization of the person's performance. So we've got Syed here was at 85% of the quota, so we consider that good. And Pamela here is 76% of the quota. Well, that's not so good. But at least Pamela is trending upwards from last year. Last year, 1 year ago, her percent of quota was only 57%. So she's not doing all that great this year, only 76% of her quota, but she's got a positive trend over last year. And conversely, we'll take, let's find somebody who's in the red here. We'll take Stephen. Stephen is almost at 80% of his quota for the year. Last year he was at 90%. So this year he's doing okay, but he's not doing as well as he was last year because he was at 90%. Now, this kind of thing over on the OLAP side would involve a calculated member to come up with a percent of quota, a calculated member to come up with a percent of quota last year, and a KPI. Remember that old game show from the 70s, Name That Tune? Well, I can name that tune in 3 components. A calculation for percent of quota, a calculation for percent of quota last year, and then a KPI where we could identify both the status as well as a trend component. So we would need 3 items to do that over in OLAP. Well, how do we do that over in the tabular model? Well, the good news is we can implement pretty much the same thing. We have to actually do a little bit more work though. Over in the tabular model, so let me hop back over to the AdventureWorks tabular model that I built ahead of time here. And let's see if I can actually pick the right project this time. If I go to the fact table called Reseller Sales Quota, I see that I've got a couple of KPIs here. Now, there's another thing about the placement of the functionality I'm not crazy about, and someone can correct me if there's another way to do this, but here the KPIs are actually included within the fact table to which they belong. Whereas over in the full-blown OLAP, there's a separate tab for KPIs. Remember that over in the version of BIDS or SQL Server Data Tools, when you're building full-blown OLAP projects, you get a separate tab here for KPIs. So they're in one place. Over in the tabular model, they are more or less going to be spread across the fact tables to which they're associated. Well, I see that I've got a percent of quota here, and it's simply the sum of the sales amount divided by the reseller sales quota. A basic DAX formula in here, but not the end of the world. And then there's a KPI built on top of that. Now, if I right-click and edit the KPI, this actually has a nice visualization tool that you really don't see over in the full-blown OLAP version when you build OLAP projects. You have to write case statements in order to say case if the KPI is between this and this, then you return a 1, a 0, or a -1 for good, bad, or somewhere in between. Here, you actually have a slider bar where you can come up with a visualization pretty easily. So I'm taking a look at the percent of quota, and I'm defining what's considered good and what's considered bad, and so forth. Now, suppose those numbers, 0.75 and 0.85, had come out of a fact table instead. I could have pointed to a measure instead of hardwiring them with the slider bars here. Now, If you have built KPIs over on the OLAP side, you know that you have a trend capability. There's no trend capability here in the tabular area. If we want to build a trend KPI, if we want to build a trend component, we have to build a separate KPI. So notice how I've got a percent of quota KPI trend. So I've got a second KPI here, and if I right-click and edit the KPI settings, well, it's simply evaluating the percent of quota trend, which is a separate calculation. That percent of quota trend is simply the quota minus the quota last year. So we have to actually introduce another measure into here to make up for this. Now, by the way, earlier in this presentation I mentioned that I had a Code Magazine article that built a tabular model from scratch. This is actually part of it. So that article, that online article that you can pull down, actually walks through the specific steps. So at the end of the day, can you build KPIs and surface them in something like Excel or another tool and get similar functionality? Yes, you have to write a little bit more code, although I do have to admit that I do like the fact that they put in a basic visualization tool so you didn't have to put a case statement in. This is kind of nice. That is a nice feature. Now, when you get to other calculations, let me come back to my slide deck here. When you get to other calculations that you might implement as calculated members, in my opinion, again, the DAX capability is no less complicated than MDX, and in some instances, now maybe this is because I've known MDX for years and I've only been working with DAX for a shorter period of time, sometimes I find DAX to be even more of a challenge. Again, it may be because I'm so used to the MDX language, but I certainly won't say that DAX is easier. And here's an example. Suppose we want to rank sales by city. Well, there's a function in DAX called rankx, and again, I'm going to have a separate program that's going to focus on DAX. We are essentially ranking each city across all of the cities. Now, there are also some other things we need to take into account. There might be a grand total, or there might not be any cities, or this might be a subtotal within a larger dimension. So if we're going to use this and put it in a pivot table, we have to wrap it inside of a couple of if statements to make sure that we have at least we have more than one city, and that the current city isn't blank, that the current row isn't the subtotal in an Excel pivot table. So sometimes you have to actually wrap some of the DAX functions inside of some if checks based upon the context of how the calculation is being used. So again, if you read that DAX is simpler than MDX, well, I have to tell you that I really strongly disagree with that, and most of the people I know who have been working with DAX actively have concluded the same general thing, that DAX is certainly not easier than MDX, and in some cases can be just as involved. Now, that percent of quota last year, there are a couple of different ways that we can go back. There's a parallel period function. There's also a function called same period last year. So there are time-based functions in DAX to go back based on the same time period a year ago using something similar to a parallel period. So again, there are functions where you see a lot of overlap between DAX and MDX. That's the good news when you go to learn DAX, but again, there can be some subtle differences between the two languages. So that's an example of creating a KPI along with some calculations in the tabular model. All right, moving on here. There is a feature that initially would seem to be very similar across both DAX and the tabular model, but as it turns out, get my terms right here. There's a capability here, and it's partitions, that would seem to be very similar between the tabular model and OLAP, when in fact OLAP actually has more functionality, and that is partitions. On the OLAP side, we can build partitions for scalability when we know that fact tables are going to get very large. Let me come over to the full-blown version of analysis services in OLAP. Let's say that fact internet sales we know is going to get very large. We might build a separate partition by year, or maybe even by quarter if it gets to be very large by quarter. I actually have known clients that have built partitions by week if they're accumulating millions of rows by week. And I actually know of one company that was accumulating about 20 million rows of clickstream transactions, and they were building dynamic partitions by day. That's pretty aggressive, but it does happen. But the example here in AdventureWorks has one partition by year. And these are broken out in the partition editor using some SQL code, where it's actually honing in on the date range. Now, Microsoft does recommend that when fact tables get to be a certain point, whether it's 25 million rows or beyond, that you start to look at partitioning. Now, the good news here is that people who write queries to go against fact internet sales, or fact reseller sales for that matter, don't need to take the partitions into account. So, back here in the browser, if I simply get rid of the fiscal year here, and I simply break out the sales by geography, by country, that's reading across the years. Analysis services will actually read across those partitions in parallel if it can. So I don't need to specify in any MDX query which partition is being used. The engine will figure it out. And again, it will, if it can, read the partitions in parallel. So partitioning has a lot of definite advantages over the OLAP side. And in addition, you can also build aggregations on top of partitions. If I know that people are going to roll up these partitions, or roll up a fact table, which might lead to queries into the partitions, by particular dimensions, we can, over the aggregation side, we can build pre-stored, preset subtotals to make roll-ups even faster. And those partitions, those aggregations are built on top of partitions. So there's a lot there. Well, over on the tabular side, there is partitioning. However, you don't get nearly as much capability out of it. Let me come back over to the tabular model here. And let me go to under the table drop down, I'll go to partitions. Well, there is the ability here to implement partitions and associate a SQL query with it. Now, okay, I didn't have it on the quota table. I think I had it on either reseller sales or internet sales. Let me get the right table here. Yeah, here we go. In reseller sales, there's a partition manager. Now, the interface here is, if anything, slightly easier than it is over in the OLAP side. They make partitioning of tabular models pretty easy. And once again, once fact tables get to be a certain size, you should consider partitioning. So I've got one here, an archive and an active partition based upon the year. However, even though when I sum reseller sales, the engine will read these partitions and it'll be transparent, and I don't have to worry about what it's going to read. It's going to figure out what to read. It won't do it in parallel. So we don't get the performance gain and the smarts of the engine reading the partitions in parallel the way we do in the OLAP side. In addition, you don't get aggregations over in the tabular model, at least not in the current release of the tabular model in SQL Server 2012. There's no ability to take this active partition and build aggregations on top of it so that roll-ups will be even faster. That capability does not exist in the tabular model. So why would you have partitions then if the engine can't read them in parallel if someone runs a query that spans the years? And why would you have partitions if we can't have aggregations on top of them? Well, what will happen is that when we implement updates, if we use XMLA to do things like process update or process incremental of the tabular model to push new data in, maybe for the year, for the month, we can hone in on the partition. So the focus of the partitions in the tabular model is to identify what segment we might do incremental insertions just into that partition. So it does have some benefit. It's just simply not as much as over on the OLAP side. So if we were doing a green check on one side versus the other, I would say there's definitely a strong green check here on the OLAP side. There's just simply more that the OLAP engine will utilize with partitions than the tabular model will. Okay, moving on here. Another capability that exists on both sides is perspectives. Now, perspectives are, in many instances, not a critical feature, but certainly a nice feature in certain analytic projects. Now, the reason you might create perspectives is this. Let me go back over to the full-blown release of the full-blown version of the OLAP project. Well, in this OLAP project, we've got many fact tables: internet sales, internet orders, sales reasons, reseller sales, and a good number of dimensions here. Well, maybe we might have some customer service reps who today only need to look at reseller sales, and they're only going to need to look at it by a couple of dimensions. And there may be other times those same people might need to just look at internet sales by a couple of dimensions. So having to browse against the full-blown cube with all the fact tables available and all the dimensions available might seem a little bit difficult to weed through. Well, we can build what are called perspectives. They are simply nothing more than stored MDX statements under the hood that limit what dimensions and what fact tables are surfaced based upon the perspective. For instance, for sales targets, maybe people go in and today they're wearing their sales target hat. The user's wearing their sales target hat, and all they need to do is look at reseller sales and quota, and maybe just by a couple of dimensions. Well, notice across the top here we have different perspectives, and down the left here the measures, the fact tables, and the dimensions that someone can see, and whether or not they can see all the hierarchies and all of the attributes or just some of them within a dimension. Now, this is not a security feature. You can't push perspectives on people. That they have to pick them. But certainly when they pick them, it's going to make things easier. Now, I'm going to actually close all of the versions of Excel that I have open here and reopen Excel. Bear with me one second here. I'm going to reopen Excel, and I'm going to go to that full-blown OLAP cube. So I will go from other sources, from analysis services, and put in localhost SQL 2012, my default OLAP server. And I will go against the AdventureWorks database, but I'll pick the sales target perspective. So the user has to pick it, but when they pick it and they build a pivot table or pivot chart, the view here is much simpler. The view here is based just on the fact tables and the dimensions that were associated with that perspective. So it's a nice feature. Definitely helpful when you have large cubes with many facts and dimensions. Well, over on the tabular side, there is very similar functionality. Under the model drop-down, there's a capability to build perspectives. And so we can create a perspective, and we can simply create a new one, give it a name, whatever name we want, and then identify what fact tables, what dimensions, what pieces of the dimensions we want someone to be able to see. So this has never been a complicated feature, but it's always been a nice one. And I would basically say that this is about a draw on both sides. I wouldn't say that one interface, one piece of functionality is really any more involved than another one. I would consider this about a draw. So a nice feature on both sides. But again, important to remember, this is not a security feature on either side. You can't push people into a perspective. They have to pick it. But presumably, if you build perspectives, people will use them. All right. This next topic is one that, to be honest, could spend almost an entire presentation just on this. And it's RoleApp versus direct query. Now, here's what we're talking about here. By default, with both OLAP and with Tabular, let's say we point to a 100 megabyte data source, or excuse me, 100 gigabyte data source, and we do a deployment. Well, we're going to have a physical OLAP cube or a physical tabular database. So we'll have a physical database that gets created when we deploy. In some instances, people might use what's called, I'm going to talk about the OLAP side for a minute, they might use what's called a RoleApp. They might not want to have to reprocess the cube in order for people to see data. They might want people, when they're working against an OLAP cube, to have near real-time access to data. Well, we call this RoleApp. It's a set of settings that we have in the fact tables and the dimension tables in the cube, in the OLAP project, so that the queries go back to the source. Now, the user doesn't know that you've got a RoleApp model going on under the hood. The user thinks that there's data in the cube that they're slicing and dicing. But actually the cube is nothing more than a virtual proxy. The Analysis Services Engine is turning around and sending SQL queries back to the source. So we call this RoleApp, stands for Relational Real-Time OLAP. Now, some people hear this and they think, well, geez, if we're rolling up a lot of data in the cube, and we don't have data in the cube, we're going back to the original source to get the data, and it's utilizing SQL queries, that's going to be a real performance hit. Well, in many instances that might be true, but not necessarily all of them. There have actually been some white papers published on MSDN over the last couple of years that have actually demonstrated that in some scenarios, RoleApp isn't as slow as you might think. Now certainly, if you compare it to an OLAP cube that's been partitioned and has gone through many aggregations, yes, that's going to outperform RoleApp big time. But if you have a basic star schema approach and you need real-time access to data and you otherwise would not have a lot of aggregations, RoleApp might not perform as slow as you might think. Now, about 80 to 90% of the people who use OLAP in general use the default model, which is called MOLAP, which means that you have data in the cube. Maybe 10 to 15% of people use RoleApp, and even that might be a little bit high. I've talked to some people who say, no, it's maybe 5 to 10%. Well, there's no way to guess that for certain, but bottom line is only a small percent of people use RoleApp, although that number has actually probably gone up a tiny bit over the years. Now, there is actually another model in between RoleApp and MOLAP called WholeApp. It's a hybrid model. I don't recommend using it. Enough said on that one. All right, let's go to the tabular model. There is an equivalent capability. You set it in the project properties, and it's called direct query. Once again, the user believes that they're slicing and dicing against a tabular model when in fact the tabular model is nothing but a proxy, something but a virtual shell. The engine is sending queries back to the original source. I really don't recommend this, or at least I recommend having full awareness of what capabilities you lose, because you could lose some capabilities in the tabular model if you utilize direct query. If you don't want to have a physical database that you have to redeploy or to incrementally update on a daily or weekly basis. If you want to have real-time access using the tabular model, you use direct query, but you're going to lose some features, and here they are. First of all, you can't do security roles, which I'm going to talk about in a little while. There's no such thing as calculated columns. You cannot have calculated DAX measures within the tabular model if you're going to use direct query. Well, that in itself would kill it for a lot of people. The data model can only have one data connection, and it can't be consumed by clients that generate MDX code. So it really can only be used by PowerView. So bottom line is you can't utilize direct query with a tabular model and expect to be able to use Excel or reporting services or performance point services, because those clients, when you go against a tabular model, generate MDX. Well, that's not going to work if you use direct query. In my opinion, this is, and again, I'm not trying to sound negative, but in my opinion, this is one of the areas where you compare it to the functional counterpart over an OLAP. There's some work that needs to be done here. This is very, very limiting. So I would really recommend taking a hard look. If you're considering using direct query, think about what you're going to lose, because this is, in some scenarios, going to be a pretty big deal. All right. Actually going to stop this and have one last video for the last set of bullet points here. So next video we're going to take a look at security roles next.